All right, so today's notes, they start with some problems that kind of review what we did yesterday in class. So I encourage you to pause the video and try these on your own, but we'll go over them together as well. So when we started yesterday talking about normal distribution, we started talking about the empirical rule and the fact that certain percentages are decided in a normal distribution based off of this rule. So if we look at this first example, it says 18-year-old women's weights are approximately normally distributed with an approximate mean of 148 pounds and standard deviation of 6 pounds. Sketch the distribution and answer the following questions. So our normal distribution told us that we're going to put the mean in the middle. So if we draw our curve, we'll put the mean in the center. So 148. And then the standard deviation is just going to tell us how much to count by going up and down. So I'm going to add 6 each time going this way to get 3 standard deviations over. So 148 plus 6 would give me 154, plus 6 more would give me 160, plus 6 more would give me 166. Then if I subtract 6, I would have 142. Subtract 6 again, and I would have 136. Subtract 6 again, and I would have 130. So that makes up what our distribution would look like. So remember, if we're within 1 standard deviation of the curve, or of the mean, sorry, if we're 1 standard deviation from the mean, that's 68% of our data lives within 1 standard deviation of the mean. 95% lives within 2 standard deviations of the mean, and then 99.7 lives within 3. So question A asks between what 2 weights do 68% of women fall? So it would be 1 standard deviation. So it would be between 142 and 154 pounds. So then our next one asks, what percentage of women weigh more than 160 pounds? So if we think about 160 here, more than 160 would just be this shaded region in here. Well, we could figure out, the empirical rule doesn't help us figure out this piece specifically, but it can help me figure out this piece, and then remember we can just subtract that from 1. So yesterday we talked about, right, if I split at the mean, this would be 50% of my data, because it's half of my distribution, half of my graph. And then I'm 2 standard deviations over on this side. So on this half, I'm 2 standard deviations over, but I'm only looking at half of my picture. So I divide by 2. So then if I take my 95% and divide by 2, this makes up 47.5. This makes up 50. So this total area is 97.5, which means this little piece would be 1 minus 97.5, or 100 really is what we should do. 100 minus 97.5, which would be 2.5%. You could also think about 2 standard deviations over is 95%, so there's 5% left, right? If I'm 2 standard deviations over, that makes up 95% in the inside, which means there's 5% on the outside. So then if we split that in half, that'd be 2.5% on each tail end. So our next question says, what percentage of women weigh less than 148 pounds? So we just kind of touched on this subject, right? The mean is 148, so it's splitting my graph right down the middle. So then 50% lives below the mean, 50% is above the mean. What percent are between 136 and 160? So that's 2 standard deviations on both sides. So our empirical rule says that's 95%. And then what percent of women weigh between 130 and 166? So again, this is 3 standard deviations on both sides. So my empirical rule says 99.7%. All right, so if I look at number 2, in designing airplane seats, the hip breadths of men are considered. The distribution is normally distributed with the mean of 14.4. So that would go right in that middle, 14.4, and a standard deviation of 1 inch. So if we just count up by 1 going this way, and 17.4, and then count down by 1 going this way, and it's not the most beautiful curve I've ever drawn. In order to accommodate 99.7% of male population, how wide of a hip breadth do airplanes need to accommodate? So if you think about the fact that 99.7, right, that was 3 standard deviations away. So we'd be at 11.4 on this side and 17.4. So if it needs to, right, the widest amount would need to be that 17.4 in order to accommodate. All right. So today we're going to start talking about standard normal. And we kind of did this when we were talking about z-scores and how z-scores we find z-scores to put it on a standard normal curve. So just some things to know. When we talk about standard normal, a standard normal is a bell-shaped symmetric curve where the mean is always 0 and the standard deviation is always 1. So this is a very specific type of normal distribution. There can be, there's a ton of different normal distributions, but a standard normal distribution is the only one that has a mean of 0 and a standard deviation of 1. So when we talked about normal distribution, we talked about this, right? We're looking at the area underneath the curve. The area underneath this is always equal to 1. We correspond area with probability. So if we find the area, we then know the probability of whatever we're looking at as well. So one of the ways that we can do this is by looking at a z-score, we can find the area or the probability underneath the curve. So if we look at our example on our paper, right, we want to find what this does. If I want to find the area between the mean, which is 0, and some z-score, this chart will allow me to find that area So what I would do, if I want to find between 0 and 0.62, I'm going to go to 0.6 here, and then over to 0.02, right? This and this would make 0.62, and this is that area that we shaded in. That is the probability or the area between 0 and 0.62. So I'd have 0.2324. So I can do that between 0 and any z value that I want. So again, if I want to find the score between 0 and 1.13, I'd go down to 1.1 and then over to the 3 for that hundredths place. And that would tell me that the area is 0.3708. So this table is great. It can tell us that area just by finding the value on the table. The only limitation is, right, we're only looking between the mean of 0 and that z value. If we wanted to find something like everything below z, the table couldn't tell us that. Everything above z, the table couldn't tell us that. So the table is limited in what it can tell us, and that's why we are going to rely on other means to figure out what the area is. So if we flip our paper over, we can find the area underneath any type, the area underneath any curve using our calculator. So what you're going to do, we're always going to practice shading in the region that we're solving for. So if we look here, we want to know between 0 and 2.34. So I want to be between 0, which is my mean, and then 2.34 would be somewhere over here. It doesn't have to be accurate. It doesn't have to be super specific. We're just looking for a sketch of what area we're looking for. So this is what we're looking for. So then to find the area or the probability, we're going to go to our calculator and we hit second vars, and I'm going to write this at the top for us to reference. And then we're going to go to normal CDF, number 2. Normal CDF. It's going to ask us for 4 pieces of information. It's going to ask us for a lower bound, an upper bound, a mean, and a standard deviation. So it's going to ask for a lower bound. So that's just when we're shading, how low, what's the lowest value that's in our shaded region, then the upper bound, so that's the highest value in our shaded region, and then our mean and our standard deviation. In this case, when we're working with a standard normal curve, our mean is always 0 and our standard deviation is always 1 when we're working in a standard normal curve. So for instance, when I find the area here, my lowest number I'm using is 0. The highest number I'm using is 2.34. Oops. My mean is 0. My standard deviation is 1. So once I have that information all typed out like this on my calculator and I hit enter, it tells me that the area of this shaded region is 0.4904. So the probability of getting a number within this shaded region is about 49%. That's what that shaded area can tell us as well. All right, so let's practice a couple more. So I want to be between negative 2.34, so that would be somewhere over here, and 0. So now I'm looking for this shaded region on this side. So again, to do that, I hit second vars. I go to number 2, which is my normal CDF. In this case, my lowest number that I typed in was negative 2.34. My highest value in the shaded region is 0. My mean is 0. My standard deviation is 1. So then when I hit enter, I get 0.4904, which if you notice is exactly the same as this one, because since this is symmetrical, right, the area, we went the same distance from the mean this way as we did this way. And the area, so since it's symmetrical, your areas should be the same. All right, let's keep looking at some examples. So now this one wants to be less than 1.96. So 1.96 is a little bit before 2, and then I'm doing less than, so I'm shading everything below 1.96. So now, anytime you're shading to the end of the graph, if you're shading to the end of the graph on this side, we're going to use negative 1e to the 99 to represent as far as we can go to the left. That represents the lowest number that we can think of. If we go this way on our graph, we'll use positive 1e to the 99. It's just giving us the smallest, lowest bound, because remember, we're shading all the way to the end of this graph. So we have to get as small as possible. So we're going to use negative 1e to the 99 when we shade on this side, and positive 1e to the 99 when we shade on this side. So for this particular problem, right, I'm going to do my normal CDF. My lower bound, right, I'm shading all the way to the left, so I'll use negative 1e to the 99. Then my upper bound, I'm stopping here at 1.96. My mean is 0. My standard deviation is 1. So that's what I'm going to type into my calculator. Second vars. To get to that e value, I'll type in negative 1. Let me zoom out a little bit so you can see my whole calculator. So I typed in negative 1. And then to get to e, if I hit second and then the division side, I get e to the 99. And then my upper bound was 1.96. My mean is still 0. My standard deviation is still 1. So then if I hit enter, I get 0.9750 as my probability or my area. All right, so if we look at our next example, it wants more than negative 1.45. So first, negative 1.45, somewhere around there. And more than means I'm shading everything going this way. So then I'm going to type in my normal CDF. My lower bound, my bound on the left, was my negative 1.45. My upper bound, remember, I'm shading all the way to the end of this graph on this side. So I use positive 1e to the 99. And then my mean is 0. My standard deviation is 1. So I'll go to my calculator. I hit second vars, go down to number 2. My lower bound is negative 1.45. My upper bound is 1. If I hit second and then the division sign, I get e to the 99. My mean is still 0. My standard deviation is still 1. So my area on this side is 0.9265. Remember, all of these values that I'm finding represent the area underneath the curve, or the probability. Remember, probability is always between 0 and 1. So anytime we're finding these values, you should always be finding a number between 0 and 1. If you get a negative value or a number greater than 1, that means something went wrong. You typed in something wrong. So keep that in mind. All of your values you should get when you're solving for these should be between 0 and 1. All right. If you're feeling confident, you might want to try pausing the video and trying the last 3 on your own, but we'll go over them together regardless. So number 9 is asking us for a z-value of greater than 1.57. So 1.57 would be somewhere around there. And then I'm shading everything greater than that. So this, again, I want the area underneath this curve. So I do what's called a normal CDF, normal cumulative distribution frequency. My lower bound is 1.57. I'm going all the way to the end, so I'm going to use 1e to the 99. My mean is 0. My standard deviation is 1. So I'll type this into my calculator. Second vars, normal CDF. My lower bound was 1.57. I'm going all the way to the end on this side, so I'll still use positive 1e to the 99. My mean is 0. My standard deviation is 1. So then I get that my area is 0.0582, which makes sense, right? This is about 5%. We didn't shade in much, so we wouldn't expect our area to be that much. So then for number 10, I'm looking between 1.23, so it'd be about there, to 2.06, so that'd be about there. So we're looking for this area of this sliver here, or the probability of getting a number between these two z-scores. So normal CDF. My lower bound was 1.23. My upper bound was 2.06. My mean is 0. My standard deviation is 1. So second vars, normal CDF. My lower bound is 1.23. My upper bound is 2.06. So my area is 0.0896 for that area that we shaded in there. Yeah, the nice thing about doing it on our calculator, unlike the table, is we can really find any two z-scores, we can find the area between the two of them. So that's a really nice part about having this calculator function rather than relying on the table. All right, so if we look at the last one, it wants the area between -1 and +1. So we want this area here. So when I do my normal CDF, my lower bound was -1, my upper bound was +1. Mean is 0, standard deviation is 1. So we hit second vars, normal CDF. I'm going between -1 and +1. And I get the area is 0.6827. And if you think about it, remember we talked about what is our empirical rule? The empirical rule says that 1 standard deviation away is 68%, and this value is pretty close to 68%. So we're just kind of validating our empirical rule that 1 standard deviation away gives us an area of 68%. All right, so that's just our intro into our normal distribution and finding that probability. We'll continue this next class.